Now I am going to talk about small group automatic winding machines, which is a step further over large group winding machines. I have given salient features of DC spooler. Now we will discuss salient features of small group winding machines, taking examples of automatic winding machines of slab host. This is the photograph of AUTOCONER 138 of slab host. This is the example of AUTOCONER 107, that is the first model introduced by Slafhost. This is one more view of the same machine. This is the AUTOCONER 138. You can see the operative putting the ring frame bobbins in a circular magazine. This is the place where you have to put the empty cones. So this is one more view of a small group automatic winding machine of Slafhost AUTOCONER 138. This is the view of an individual spindle of AUTOCONER 138. The knotter moves on the back side of the spindle, that is over here, and perform the knotting operation. So in earlier machines it used to be knotter, in later machines it was the splicer mainly. This is the photograph of a splicer. So this is the splicer. So you can have splicer or knotter. So the whole unit remains the same, only the yarn joining unit has to be changed if you want to move over from weaver's knotter to fisherman's knotter or to splicer. Let me explain passage of yarn through AUTOCONER winding machines. This is the diagram of passage of yarn through AUTOCONER 107. This is the photograph of AUTOCONER 138, which is an improved version of AUTOCONER 107. So coming to this diagram, this is the ring frame bobbin. This is the unwinding accelerator. You have a pre-clearer. Prior to that, there are two yarn guides. Then you have a gate filler. This is yarn tensioner. Then waxing device. This is the slub catcher, mechanical slub catcher. This is the detector wire, that is, it is a mechanical sensor that senses the presence of yarn. Then yarn goes onto the drum and then onto the package. This is the spindle of AUTOCONER 138, some elements are principally the same with some changes. So now let me explain you the functions of various elements. This is the supply package, that is the ring frame bobbin. What you can see here in this photograph, so this is the ring frame bobbin. This is the unwinding accelerator. What you can see here, this is the unwinding accelerator. Then yarn passes through a pre-clearer. Same thing I will show in a close-up photograph of this machine, that is AUTOCONER 138. So here you can see these two. So yarn coming from the unwinding accelerator, it passes through a first yarn guide, then you have a second yarn guide, what you can see in the diagram here. Then you have a pre-clearer. Pre-clearer in diagram is shown here. So this is the pre-clearer. Then you have a gate filler. Now, function of unwinding accelerator, that is this one, is to minimize tension fluctuations. This pre-clearer, it acts as a pre-clearer, that is, main clearer is already provided subsequently, but the function of pre-clearer is to arrest any loose pieces of yarn that is adhering to this incoming yarn. This pre-clearer is a mechanical slit type of yarn clearer. Next element is the gate filler. This detector wire detects the absence of yarn, that is, whenever yarn is absent here in the detector wire, the spindle stops. Stoppage of spindle can be because of two reasons: either yarn break or package exhaustion, that is supply package exhaustion, that is exhaustion of this ring frame bobbin. So whenever the knotter comes on the spindle, the knotter should know whether only yarn breakage has taken place or the ring frame bobbin is exhausted. This detector wire cannot know whether the ring frame bobbin is exhausted or yarn is broken. So to distinguish between yarn break and package exhaustion, this gate filler is provided. So this gate filler has gate kind of things. This is something what you can see here in this figure. This is the gate filler. This arm, that is one arm of the gate filler, is fixed. You can see the and the other arm can swing. What you notice here is that the two gates are away from each other. This gate filler remains open during winding. the moment yarn breaks and spindle stops, the movable arm of the gate filler moves towards fixed arm. That is, this movable arm, try to see here, will move towards fixed gate and try to penetrate in it. If yarn is present, the gate won't penetrate. Gate is stopped by the yarn. So if gate is stopped by the yarn, that means that ring frame bobbin still contains the yarn. So in that case, the spindle stoppage is due to yarn break and the knotter has to perform only knotting operation. That is, ring frame bobbin is not exhausted. So the knotter has to take the yarn from ring frame bobbin, from winding package, tie the knot. If yarn is absent here in the gate filler, that is, if spindle stops and yarn is absent here, then the gate will penetrate fully. If gate penetrates fully, that indicates that the ring frame bobbin is exhausted. Please note that you are not sensing at ring frame bobbin to know whether it is exhausted or not. But when yarn is absent in the gate filler, it is considered that the ring frame bobbin is exhausted. But it may not be the case always. Now, the question may come that why do we not sense on ring frame bobbin to know whether it is exhausted or not? The reason is that during splicing or knotting cycle, the arm that picks up the yarn from the supply package, it takes up the yarn at this point, that is at this location. So that is what you can see in the figure here. So the gripper arm that picks up the yarn from supply package, it picks up the yarn here. It cannot go on the ring frame bobbin to pick up the yarn. So if yarn is broken, say at the unwinding place, that is, say if yarn is broken at this place, say at unwinding accelerator or just while emerging from the package. In that case, even though yarn is present here, knotting will not be possible because the knotter is going to pick up the yarn from here and yarn breakage has taken place on the package. So if the yarn breaks here, then you have no option but to change the entire ring frame bobbin. Therefore, occasionally you will find some ring frame bobbins which are ejected from the spindle, which are non-emptied, but they will be ejected when breakage takes place below the gate filler. Say for example, above in this pre-clearer, if say something is wrong with the yarn and if the yarn is trapped at the pre-clearer, yarn would break here at the pre-clearer, and in that case there will be no yarn in the gate filler and the change will take place. Let me also tell you, now coming back here, that this is the pre-clearer. So what will happen if yarn, say there is slough off and yarn is trapped here in the pre-clear end and breaks. Now the gate filler will say that there is no yarn, and so decision will be taken to eject the bobbin. Now all of you please attend here. That situation is like this. This is the yarn and it is trapped in the pre-clearer, and there is no yarn in the gate filler, so this is going to be ejected. So if this ring frame bobbin is ejected, its yarn is still caught in the pre-clearer, so there will be difficulty in ejecting the bobbin. So to take care of that, below this guide a scissor is provided. That used to be called as a lower yarn scissor in AUTOCONER 107. So here there will be a lower yarn scissor. So whenever the bobbin is to be ejected, that scissor comes into action here. By chance, if any yarn is trapped in the pre-clearer, that cutter will cut the yarn prior to ejection. Ejection means this bobbin is going to be thrown out of the spindle. So if its end is caught here, there will be difficulty in ejecting. So one more element that is not shown in the passage is a lower yarn scissor which is located here. Yarn tensioner on AUTOCONER 107 and 138 had unique features. You can see its diagram here. The tensioner consists of a disc. Unique feature here is that this disc was driven by a separate motor. So this disc gets a continuous drive from a motor when winding is going on. A double tension shoe is pressed against the disc and the yarn passes between the shoe and the disc. Thus, this is an additive type of yarn tension. This is the photograph of the tensioner. Let me magnify this for better clarity. So you can see the magnified view of the yarn tensioner, wherein this is the yarn, this is the shoe, this is the disc, and this is driven by a separate motor. So this was a unique feature in the yarn tensioner. Now the passage of yarn is like this. So yarn doesn't pass through the center of the disc, but it is off center in such a way that the surface movement of the disc is in the direction opposite to the yarn travel. I will clarify this in the animation. This is the animation of yarn tensioner. This is a shoe. This is the disc. So the disc of the tensioner rotates, and this is the yarn. So as you can see that in this portion, the surface of the disc rotates in this direction, whereas yarn is moving in this direction. So the movement of the surface of the disc here is in opposite direction to the motion of the yarn. Thus, the rotation of the disc gives the self-cleaning. So it will not allow any fluff to accumulate in the tensioner, because accumulation of fluff in the tensioner will reduce the tension applied by the tensioner. So the rotation of the disc by a motor is advantageous, that it does not allow fluff to accumulate. The fluff is driven out because of the centrifugal force. The other advantage of the disc rotation is that it will cause even wearing out of the disc. So this shoe is made up of a wear resistant material. Now the tension applied by the tensioner can be adjusted by the torsion of the spring. So this is the end of the spring. So if I shift this end this way or this way, the torsion of the spring changes, and thereby it changes the force with which the shoe is pressed against the disc, and thereby the friction force is changed. So basically, by moving this end, you change the normal force here, and normal force changes the frictional force. So to change the tensioner, one has to move this end. Now over here in the AUTOCONER 338, there are different colored bands provided, say yellow, blue, green, and a setting range used to be provided, whereby uniform setting on all spindles can be ensured. So you have to summarize about this tensioner, that what was unique feature of the tensioner then is the drive to the disc by motor and easy setting. Now this spring stiffness, there used to be 3 spring stiffnesses provided. So for finer counts, one has to use a spring with low stiffness, and for coarser count, the torsional rigidity of the spring has to be increased. So finer counts, spring with low torsional rigidity, and for coarser counts, the spring with higher torsional rigidity would be used. So this was the tensioner. So it was much improved as compared to the tensioners which were being used prior to this. Plus you also note that there is no deflection of the yarn in the tensioner region. Thus, this yarn tensioner was advantageous in different ways.